Well, what we're trying to do now is to find an equation of a line from a known point and the gradient. So, for example, if we have a line that passes through 3 and 5 and has a gradient of 2. So these are the information we have been given, and we're trying to find the equation for it. So the most straightforward approach is to realize that the default line equation is y equals to mx plus b. We have our m here, and we also have our x and y. Yeah. So the idea is that if we substitute this y into the equation, we have to, if we substitute this x into the equation, we'll have to get y. Yeah. So what this means is that y is 5 equals to 2 times 3 plus b. So we just substituted back everything into the equation. The only unknown here really is the b term. So or we can say that equals to 6 plus b, and b obviously is -1. We have our m, we have our b. So we substitute into the line equation, and we can say that y equals to 2x minus 1. Here is our line equation. Well, there is another approach. If you think about it, if we have a number plane, and this particular line that passes through 3 and 5, yeah, passes through like this, then we can say that anywhere along this line, the gradient has to equal to 2. Yeah, which means that if I pick an arbitrary point anywhere here, so for example here, which I call x and y, it doesn't matter where this x and what this xy is exactly. We just can try to work out the gradient. So obviously the change between this point and this point is x minus 3. Yeah, so the second x value minus the first x value. The rise will be the second y value minus the first y value. So here's our rise, here's our run. Because the gradient has to be the same along the entire length of a straight line, so we can say that this rise over this run has to equal to 2 as well. So y minus 5 over x minus 3. It has to equal to 2. Yeah? So this expression, we just have to move things around a bit. So obviously equation, get rid of the denominator, we multiply both sides by x minus 3. Yeah. So we end up with y minus 5 equals to 2x minus 6. Remember, distribute 2 to both x and 3. And then get rid of this 5 with plus 5 to both sides, and y equals to 2x minus 1. Exactly the same. So two methods, they yield exactly the same results. Okay, let's try another one. Say example 2, even though I never really had example 1. So example 2, let's say it passes through passes through 0 and -2. Yeah, and it has a gradient of -1.5. So once again, we can try both methods. Firstly, we realize that here's our x, here's our y. So -2, the y value has to equal this gradient, 0.5 times the x value plus b. Yeah, of course, any number times 0 is 0, so all that left is b. So b equals to -2. And we can say that the equation of the line should be y equals to -1.5x minus 2. Alternatively, we can use the second method. So imagine that we have a number plane once again. Yep. Yeah, so the line passes through 0 and -2. So it passes through here. 0, -2. Yeah. And has a negative gradient, which means it slopes downwards. Yeah. So if we choose another arbitrary point, say x and y here, we can say that the run on this side, the run is x minus 0. Yeah, x minus 0. That's our run. And the rise is y minus -2. So once again, we have our rise, we have our run. The ratio between them has to equal to -1.5 because it's along the same straight line. Yep. So y plus 2 over x equals to -1.5. Y plus 2 equals to, so we multiply both sides by x to remove this denominator, 1.5x, and then we minus 2 from both sides to remove this 2 here. So y equals to -1.5x minus 2. Yeah, exactly the same answer as before. The point is, if we have a line with a known point, of x1, y1, if we already know where this particular point is, and if we know that the line has a gradient of m, then we can say that if we choose any arbitrary point xy, then y minus y1 over x minus x1 has to be m. So when y1 and x1 are known and m is known, then we can just move things around a bit to find the equation of the line. Of course, another way of writing is to move x minus x1 to the other side. And if you're really keen on memorizing formulas, then these are the ones to remember.